Hello there, Internet. Today I'm here to talk to you about technology. Now, isn't technology cool? I'm reading my script with technology, I'm talking to the camera, that is technology, and you're watching it on the other side of your screen, which is also technology. Very cool. But how does this all work? Well, we can explore all of that later, but for today, let's talk about one of the most important principles in fundamental programming, that of recursion. Recursion. You didn't think I was going to be able to make it all through an episode of this without making one recursion joke, right? So as you saw in that hilarious joke there, recursion is basically when something is happening inside of itself over and over and over again. So when it comes to programming, this basically means a function is calling itself back inside of its code. Now you might be saying, why, that sounds really complicated. I'm just going to use a loop. Well, I mean you can, but there's always a cost that comes with simplicity. Recursion is harder to implement because it's such a new concept for so many people, but once you actually use it, it's much more extensible, so you can actually reuse that code later, rather than having to make an entire new loop structure from scratch every single time you want to reuse it. Recursion is a lot less prone to errors, since the actual code compiler handles a lot of the data management itself, rather than putting it on you, the programmer, to figure out how exactly to type that yourself. So whether it's sorting or creating complex algorithms that call back to themselves multiple times, recursion certainly has its place in the programming world. But now Josh, you say, how exactly do you do this if it's so complicated and new? Well, it might not be as hard as you think. To make a recursive formula, we can use the divide and conquer techniques, which is a lot like what the Romans did, except with a lot less helmets and spears. Essentially, you take the program and divide it into smaller and smaller pieces until you can evaluate each one separately. And then boom, recursion. To make it easier to understand, let's actually do one of these. How about a nice geometric series? Triangle, square, pentagon, circle, what's that? Wrong geometric sequence? Apparently the hardcore math gods have decided that that's not right, and instead a geometric sequence is some sort of like array of numbers in an ordered list where they all have to be arranged by some common ratio, but you know, I'm going to stick with the shapes thing. So here's the problem. It says that we have a geometric sequence of 3, 6, 12, 24, ... Now, it asks us to find the 143rd term? You're just multiplying by 2 every term. But I'll tell you what, I am not doing that 143 more times, or else this video will never end, and I have other things to do. No, there's gotta be a better way. That easier way, mind you, is recursion. So let's divide this and then before we conquer it, you know? So each step you multiply by 2. So naturally that's going to be our singular step, since it's one repeated process over and over again that builds upon itself. So now we get to use the 3S strategy. So those steps stand for simplify, which means that you break down the problem into smaller pieces and start evaluating them. The second S stands for solve, where you get the base case and actually use the number or other set of data that you're provided to plug that back into the equation. And the last one is salami, where you celebrate by going and getting a salami sandwich and leaving this whole computer thing behind. Yeah, sadly, that's not actually what the last S stands for. It stands for substitute, which is kind of cool, I guess. Basically what that one is you just take your final value and plug that back in to each equation before that until you get all the way back to the thing that you're originally trying to evaluate. So you basically do each step in the process. Cool. So let's define a function here. Let's call it geo. It can have one integer input that we just create, and I'm going to call it index. And it returns another integer, you know, its output. Well, so if the index of the thing that we're looking for is the 143rd term of this geometric sequence, then the index for this point is going to be 143. So we have geo of 143. But now, thinking about it, if GO of 143 is just 2 times the number below it, well then we can just say that GO of 143 is equal to 2 times GO of 142. And GO of 142 is just 2 times GO of 141. And so on, and so on, 140 more times. So if you keep doing that and doing that, you get all the way down to GO of 1. And if you look back at the original sequence, you can see that the first term is actually 3. Congratulations, we just solved everything. So thank you guys for watching. I hope you enjoyed this video. Make sure you like or subscribe down below and maybe leave a comment about what sort of computer science... yeah, I'm just kidding. We still have more to do. What we have to do now is the last letter in the SSS process. Substitute. So if GO of 1 equals 3, then GO of 2, which is, if you remember, equal to 2 times GO of 1, is 2 times 3, which is 6. And now keep going and substituting back into each original equation until you get all the way back to GO of 143. So I'm not actually going to do that. Instead, I'm going to write a program for it. Let's take a look at that now. So this is what the program is. It's pretty simple, right? The program just calls itself index down and then multiplied by 2. And if I run that program and evaluate it, you get... oh man. 1.67255589 times 10 to the power of 43? That's a pretty big number, but hey, we got it, right? So hopefully now that you see that maybe recursion isn't as scary as you originally thought it was. And it's certainly not the scariest thing you'll see in computer science. That honor is still reserved for Windows Update. Hopefully you didn't have anything due tonight. So thank you guys for watching. I hope you've enjoyed this video and learned something a little bit about recursion too. If you like these videos, make sure you click the like button or subscribe, or both. Maybe leave a comment too if you so desire. And if you liked this video, you can check out this video up here in the corner about recursion. Recursion. Yeah, that's enough of that.